To speak about dynamical mechanisms that support barred spiral structures. So the kind of objects I will deal with is like the two known barred spiral galaxies, grand design objects that you see there, like NGC 1300 and 1365. And this is a chance to present what has been discussed in after previous talks, what results can be given by modeling spiral galaxies like autonomous Hamiltonian systems. This is the kind of modeling I have used for what I'm going to present you, and it is something that we try many years for now. The general idea is that one has a reasonable assumption about the kind of potential that represents the galaxy or the class type of galaxies he wants to model, then puts some, doesn't really have so much to do how many, but some thousands of particles on a disk, gives them some initial conditions, let's say circular motion, and then imposes the potential, observes what will be the response, and compares the results with some given surface photometry and kinematics. So this procedure has been tested in normal spiral galaxies, I mean non-barred spiral galaxies. And here I give you an example. It's not my subject tonight, but I give you an example of what can be the comparison with specific galaxies that such a modeling can give. There is a kind of flow that it is behind this model. The flow of both stellar and gaseous component is around the center of the galaxy, and you may understand why usually we call this kind of flow precessing ellipsis flow. So it is the typical sketch of a density wave using precessing ellipses. Okay, the flow in this case is like that. Here, if it was gas, for instance, it comes to the potential well, shocks, and makes all what we heard also in the previous talk. So, okay, but my subject is now about barred spiral galaxies. So, the motivation is, for instance, to check if the flow is the same and under which circumstances. And and it's something that several groups occupied with in the last, I would say, 5 years. And the main result is something that I rush to say from now on, is that studying these spiral galaxies with bars, the main thing is that not only regular but chaotic orbits play a crucial role in shaping the observed morphology. So by that I realized I forgot to tell you that in the stellar counterpart of this model, following the same flow, the motion is mostly regular. And I give here all what I could find in ADS. Of course, I cannot have to be occupied with the subject. This is a paper that one should read to understand the dynamics of the orbital dynamics. If you have the bar, actually, you cannot have them aligned on a circle like that, but focus on the first slide. What is the procedure? Here we get a potential out of and here is a response model that corresponds to this galaxy. You see that the basic feature of the spirals of the galaxy. Now, in that, for instance, case, one orbits that are classified as chaotic have been armed, and here are some of the orbits that in the outer envelope of the bar in the paper of 97 attempted to model NGC 1300. We have some good and we have taken the potential for this galaxy and we tried first to understand the dynamical mechanisms that act the specific structure. Actually, as you will see, this is, when we finished our work, we realized that this was not the interesting part. The interesting part is to understand dynamical mechanisms that appear. So just very fast going through the potentials that we have used, we have taken limiting cases. So the potential is fully describing the asymmetries observed in the density, in surface density cylindrical geometry. So the models that I will show. Okay, so just to give you also an impression about how the perturbation symmetric part of the Fourier analysis, you see that one arm is continuous with all pattern speeds that we have examined in depth in terms of orbital. The point is that we have all these Lagrangian points. This was here we can have also a comparison with the isophotes of the galaxy. So here is our response. It's very nice to reproduce actually, but somehow we fail to do the same. Done a kind of detailed orbital analysis, and for that because we are in a rotating frame of reference, and here is how such a histogram may look like, and then out of that we can see for instance, which is the energies that our particles have when they shape the structure that we see in our response model.